Hello, hello, is this thing on? Anyone who's here, drop something in the chat to let me know that the audio's coming through. First time stream, I did do a dry run a few days back, but just in case anything goes weird, let me know if you can hear me. Oh, well, I guess we'll hop into this in just a sec. How's everybody doing today? Everyone have a good new year? Oh, well, a little bit difficult to get used to this format. I've played around with live streams, but never actually gone live before. It's fun when things show up on a different screen than what they're supposed to be, but scuff is expected at this rate. Okay, so I guess first up will be a little bit of an FAQ for the... on the UPS project. Had quite a few comments come in. In fact, that's definitely the most activity any of my videos have gotten, especially in such a short time. And in a way, I consider it maybe the most deserving, but who knows? Alright. Gonna go get the FAQ queued up. And some responses if anyone has any further questions they'll want to drop. Let me know. Okay, I guess first is going to be probably something that was not the most consistently commented about, but consistent enough that I might as well address it, is ew, the music, what the heck? Alright, I'll admit, it was a poor choice, especially the short length of time of the loop and the choice of music was something where really should have made a longer loop, chosen a different song, and dropped the level a little bit further. I think the reason was normally I get quite annoyed at background music, and I'm usually more accepting if the music doesn't annoy me, especially if I've spent probably 2 or 3 hours in total listening to it, especially during the editing process there. So because of that, I made a bad choice in that it didn't annoy me, but a significant number of people commented that the music was a problem. So I'm working to improve on that going forward. It's need to be better about choosing the songs. Definitely if I'm looping something, doing it for a much longer stretch of time so it doesn't as noticeably repeat. And of course, dropping the level down a bit just so that it's going to be just a little bit less prominent. Part of the mistake could be that I just have a good set of headphones that makes it a little bit easier to tell and discern my voice from the background music. For example, I can crank it way, way down to only a few percent volume and hear my voice quite clearly, and the music is essentially gone, lost to the noise floor. But somebody else might end up being in a position where they have to crank the volume to hear me clearly, and that means the music is more prominent in their system, and it's a little bit more jarring for them to listen to the same song. So, yes, the music is something that I am going to fix going forward. Okay, something else. Next up, modified sine wave. Oh, the horror. Oh, that's part of the reason why it's nice having someone to help me along, is I've been streaming with the mic muted the whole time. Oh, that's fun. Thanks for not indicating that very well. Okay. Picking up where I actually left off. Oh, this is so scuffed. So, modified Sine will destroy the computer. EVGA will list on its official FAQ that its power supply's input stage will work with modified Sine. This isn't true for all manufacturers or models. The issue stems from the input stage with active power factor correction, which uses an initial switching stage to force the current waveform of the input to closely follow the voltage waveform in the shape of a sine wave. This results in a very high power factor, typically in the 0.95 and above. Some of the really good input stages can essentially approach unity. There will be some minor harmonics, so 0.98, 0.99 is a typical max. However, this presents a little bit of a problem if the power supply is fed with a waveform that is not a sine wave as it was designed to accept. Modified Sine has a period of 0 voltage, a square wave peak up to the nominal voltage, goes back to 0 for a delay, and then goes to the negative peak. This causes an approximation of a sine wave, but still has significant harmonics, and certain input stages with active power factor correction may misbehave if that's what they're fed. Most common issues are either overheating of the input switching MOSFETs because they're not designed to handle that kind of pulse, or sometimes overvoltage and premature degradation of the input reservoir capacitor, simply because the average of the modified Sine can run slightly higher, or confuse the input stage into being a little bit more aggressive with its regulation. This, in rare cases, could cause a weak input reservoir cap to actually punch through and catastrophically fail. In my case, EVGA has essentially ensured that their supplies are robust enough to handle modified Sine for typical amounts of runtime. Alright. Caught up there. Onto battery safety concerns. One of which is that battery is going to spray acid because it's not completely sealed. And my rebuttal to that is, any lead-acid battery type will vent if sufficiently abused. It doesn't matter if it's gel, AGM, maintenance-free, valve-regulated, anything of that type has liquid electrolyte, and in the event of a major failure, that electrolyte can be heated to the point of boiling, and any vent situation it has will be overwhelmed because it is typically meant to handle a very small amount of off-gassing from normal operation, whether charge or discharge. In the event of a major failure, the battery is going to spill. Doesn't matter what type. I have seen this myself firsthand. The battery, in this case, came close to rupture, but did not. It was a sealed, I believe, glass mat type of similar setup to what would be found in a motorized wheelchair. In this case, it was on a high school first robotics robot. I didn't see what caused the battery, but suddenly there was some shouting, and a fellow mentor from a neighboring team in the pit area carried a very swollen, very unhealthy looking battery out away from the people, and we had to evacuate. Ended up being some sort of short circuit in one of the cells, I think. It never vented, but was scary to see the battery swollen up like a balloon and probably close to popping like one. Eventually, it cooled down, all of the energy it had was expended, it was put in a bucket full of baking soda and carried out of the venue, and we could return to our duties. Problem solved, and still a little bit spooky to see, but goes as an example of any battery can run into a problem if it encounters sufficient abuse. Alright, going on with battery chemistry concerns is, what about hydrogen? Ooh, scary. I'm going to blow myself up. I'm going to blow the house up. What fear-mongering? Hydrogen is quite explosive. It's a material that is extremely difficult to handle. In this case, part of why I seem maybe nonchalant about it is related to the quantity of hydrogen that could reasonably be produced by one of these batteries. The battery is sitting on a float charge. Right now, I can look down under my desk, and it says 13.6 volts DC. At that rate, and effectively zero current, the charger is only compensating for the battery's self-discharge. Very little gas is produced in this float or maintenance type of charge state. If it were producing significant hydrogen to the point where it could present an issue to my safety in the house here, any battery hooked up to a maintenance type charger would fail in a matter of weeks from all of the electrolyte being off-gassed. The volume of hydrogen produced by a single battery that is not being heavily cycled is largely blown out of proportion. The issue would be if I were to have a bank of batteries in a similar application. Say instead of running one relatively light computer for a couple hours, if I were building a system to run an entire small office off of one backup UPS supply with a rack of batteries, essentially commercial grid storage type lead acid, surplus forklift batteries, that type of setup, that is an application where hydrogen suddenly becomes more of a concern. Each battery, despite its small amount of off-gassing, will compound the effect. More batteries, and there's more hydrogen released in the same amount of space. If there is additional stress on the batteries, in this case being if there's additional cycling of the batteries, whether for testing purposes or during normal cycling use, if the site frequently needs to dig into its backup supply, that will cause a lot more off-gassing of the batteries, as most of the gassing will happen during either discharge or recharge cycles. In those cases, certainly additional safety precautions are required, and that would be forced ventilation, ensuring there's sufficient air change in the area where the batteries are stored, hydrogen gas detectors, which will alarm at 1 or 2%. Hydrogen's lower flammability limit is 4% in air, so as long as the alarm sounds well before a significant amount builds up, that will allow appropriate increase in ventilation and or evacuation to render the site safe. The batteries will be also equipped in that sort of situation with a catalytic recombiner. This means that each cell will, instead of venting to the atmosphere or venting outside, will send its hydrogen and oxygen up into a chamber with a specially designed catalyst. The catalyst will induce the hydrogen and oxygen to recombine, generating some heat and water. The water is then cooled and condensed by the assembly and is allowed to drain back into the cell, This not only captures most of the hydrogen the cell would produce, but also greatly reduces maintenance cost because the cell does not lose water nearly as quickly as it would were it simply allowed to vent. In my case, one single battery not being heavily cycled in a 1960s building with significant air exchange per hour, there is not a huge amount of venting of hydrogen here. Certainly not enough to be an explosive risk in something the size of the bedroom, let alone something the size of this entire house. Okay. Next up, copy and paste that in. Why is that all bold? Formatting, please cooperate. Thank you. Alright, what about lithium, iron? Yeah, what about lithium chemistry batteries? Lots of people were suggesting or expecting me to use one of those instead of a conventional lead acid. In my case, it was largely based on cost. While some people did present some decent suggestions for the ballpark cost, for my area, especially for any sort of video, ha, I can totally speak. For any sort of battery that I would be able to buy locally or get shipped locally in my area, would at the bare minimum have doubled the cost of this project. In some cases, it could have tripled the cost of the project. And I would also want to make sure that whatever battery I was getting was a high-quality battery. I really don't want some cheap lithium battery inside the house. To me, that's way more of a risk than the lead acid. Lithium batteries can be quite a bit spicy if they're not charged correctly, or discharged correctly, or stored correctly. The modern chemistries are significantly safer than they used to be. There's still a little bit of a hesitation point for me for something that I'm installing inside the house. An assembled lithium battery inside of, say, a power bank, those I trust a little bit more, mostly because those have been through the testing that will ensure that under most reasonable and even some unreasonable conditions, the assembly as a whole will remain safe for the people that are using it and the places in which it is kept. That said, the instructions on those are likely going to have a whole set of paragraphs about what to not do to it, just to cover the rear end of the manufacturer from somebody coming after them because the power bank decided to let the flamethrower effect out. That goes on to the next one. Pop this in here. Lithium would need its own battery management system if I were to do that. It's a little bit, depending on the battery management, many will come with the battery manager built into the battery. Some will require or encourage an external charge controller battery manager just to be on the safe side. So between that and the cost of the material for the battery, that would have significantly boosted the cost of the project beyond what it cost originally. Part of this was a, could I do this for cheap? In fact, to begin with, I was going to just play around with a supposedly dead uninterruptible power supply that I didn't know why it was dead. It could have been completely mundane, like the battery was dead, or it could have been worse, like the entire inverter had decided to have a meltdown. Didn't know until I started taking it apart and found what I found. So, project was kind of a bargain bin endeavor from the start. So, that's why I didn't start with a top-of-the-line UPS. It was in the scrap pile, and figured, why not? It's only when it proved to be sturdier than I expected, and that's when I decided, I could do something with it. And then that most recent power outage happened and got me annoyed enough to turn it into a whole project. Alright. Something else that comes up related to both of those is just buy a huge power bank with a built-in inverter. Several viewers have suggested some pretty cool items, the sort of thing where, in the future with more budget, I'd be interested in having, both as the backup power source and to do a product review of. A few things of note that I found when I looked a little bit deeper into those is they often had a fairly long transfer time in their UPS configuration. They claim to have UPS functionality, essentially a pass-through type or a transfer type. The datasheets I found did not specify whether it was an online type or an offline type. However, I'm leaning towards offline type, both for overall efficiency of the product and because they typically listed a transfer time of up to 30 milliseconds. Typical for UPS is somewhere between 8 and 12 milliseconds. The specification for an ATX PC power supply is it must have a minimum holdup time of 16 milliseconds. Because a 30 millisecond is almost twice that, that would pretty likely cause my computer to black out during the transfer process of one of those power banks. The other thing that we found was there's a good chance that of the power banks I saw on the market, in order to get the runtime that the one I built would get, I'd be looking at probably $1,000. So that was a little bit of a turn-off and also blows the cost of a homebrew lithium power pack for my project completely out of the water by a factor of probably about 2 or more, maybe 2.5. So the cost of that would be quite a bit higher, and that would just be getting to the runtime of this unit. The advantage of one of those would be the inverter output capability of one of those power banks is actually quite impressive. Having a portable, probably 12 to 15 pound power pack with a almost 1,000-watt inverter built in, and being able to provide an hour or two of runtime at that level, that in itself is impressive. Okay. Something else that kept coming up is Hey, the fan is blocked. There's no airflow. For that, I am going to have to pull up the video itself in order to better show what I'm referring to here. In that the fan has quite a bit more access than it would first appear, though I did make a mistake in the video in not pointing out how the assembly went together and how that airflow path was fairly free-flowing. Go to the render bucket here. The fan has a Alright, the fan on through all the searching here to the final assembly. Bring this over here. On the top of the battery box enclosure, there's this fairly deep channel. It goes through to both sides. A little bit taller in the middle, but the sides drop down probably about half an inch, maybe slightly larger than that. So there's a decent gap right there on the battery box lid. If I continue to scroll forward, where I placed the Velcro, the dual lock, take note of where this piece is in relation to the intake for the cooling fan. And then slightly further forward, there's that Velcro, and right next to it is that channel in the battery box lid. Scroll further forward until there's a side view. There's the Velcro again in relation to the battery box lid and the channel. You can also see how the Velcro pad itself has lifted up a little bit. So between that, there's a significant channel aligned with the fan intake that lets plenty of air in. The fan itself is probably a little bit overkill for the amount of cooling actually required, especially since some people have come in and mentioned that they've hot rodded one of these units and didn't really have any overheating issue. Copy here and drop in some notes from that. Alright. How long does it take to charge? Because that seems like something else that was brought up somewhat frequently as well. How long indeed? In this case, it'll get there eventually. The charger on the UPS is definitely more of a maintenance charger or a float charger rather than a recharger for a battery of this size. For the little 7 amp hours original battery, yes, it's plenty. Within a day or two, the battery will be filled pretty much full. For this battery, if it gets there, it will be a matter of probably a couple weeks. That's why, in this case, I will need to make a trip outside and hook up an external charger in order to bring the battery up. This may not be such a bad thing to recharge the battery with a booster charger, simply because the battery will stratify sitting as it is, again because of the extremely low charging current, essentially zero current except for the self-discharge. Because it's unable to stir the electrolyte at that rate, the electrolyte will eventually start to spread out, which will definitely cause some problems with the battery's capacity, even if all of the electrolyte material is still present in the battery. Putting the battery under a load will cause convection in the electrolyte, as well as the bubbling of hydrogen and oxygen off the plates. This stirring effect will redistribute the electrolyte. Therefore, as part of my maintenance for this unit, I will be probably quarterly checking the electrolyte levels and giving it a little bit of an exercise. Drain it down to, I don't know, maybe 75-80% of full charge, and then completely bring it up through a full charge cycle at significant current, probably about 5-6 amps, which should be enough to redistribute the electrolyte and ensure the battery remains healthy. This is a cheaper battery. I got it at the auto parts store. It is a deep cycle type, or claims to be. Whether or not it has all of the bells and whistles of a deep cycle, I'm not entirely sure. It does suggest it in that its cranking amps level is much smaller than a start-only Group 27 battery would have, which tends to suggest that it is a deep cycle, or at least a deep cycle, somewhat leaning type battery. The way the plates are set up they are thicker, they have less surface area. This means that they're less susceptible to sulfation and flaking off when deeply discharged, but it also means that the battery cannot provide the surge current in a starting application. They absolutely can be used to start, they simply won't provide as much starting current as a equivalent size starting duty battery. Somewhat of a in-between would be a hybrid, a dual purpose, a start and house combo battery. That's kind of a compromise between deep cycle type and a starting only. The plates are a bit thicker and more reinforced. They have some optimization for surface area and starting current, but not as much as a start battery. At the same time, they also don't have the same amount of plate material, and the plates are still a little bit more susceptible to sulfation and flaking. So they're jack of both trades, master of none. But that said, especially for short-term use, a starting battery can be used for deep cycles. It will simply be damaged more easily and wear out sooner. Meanwhile, a deep cycle battery can be used for starting duty. It will simply not provide as much starting current as expected for a battery of that size. In many cases, it will be absolutely sufficient for starting, but in the case where the original battery was marginal, especially for a larger engine in a much colder climate, that's where starting output of a deep cycle battery might fall short and cause issues with starting an engine. Okay, moving on from there. Alright, first start. And alright, probably get a new page in here. Alright, about the alarm buzzer. Why did I keep that absolutely just ear-piercing alarm buzzer? Yes, it is absolutely ear-piercing. Before I put the volume control on, in fact, during the section of video where I did the hour-long long endurance test, the piece of tape that I used to mute the buzzer fell off. So the entire time I was monitoring it, I had my headphones on trying to escape the noise while also staying close enough to monitor the camera and the temperatures and the unit just in case something extra exciting happened. Yeah, that was fun. The main reason I kept that alarm buzzer is I had already gone to most of the work of breaking out its signal from the board in order to get the fan control signal. At that point, it was extremely trivial to mount the buzzer on my little proto board and add a volume control. I know that there is software for these UPS units that can be used to modify some settings. At the time, I didn't have the cable for this, and of course, I wasn't going to get one until I was sure this project would be successful. Instead, I opted for the old school of put a pot to turn down the signal to the buzzer while keeping the signal for turning on the fan. In this case, it's useful because I keep the buzzer turned all the way up normally. If I'm at my computer, yes, it's quite obvious that the power's gone out. 2 out of my now 3 monitors will go blank. I'll hear it click, I'll hear the fan spool up. If my light is on, I will see the light dip out and come back for a split second. However, the main reason why I wanted this unit was when I am encoding a video, I will typically start the runtime and then I'll walk away. I don't need to be using my computer. Anything I'm using the computer for will slow down the render a little bit, and I can go get a snack, do laundry, run an errand, who knows what, and I want to be able to know, even if I'm anywhere in the house, that, hey, the power's gone out, I should check on my equipment. That's why I decided to keep the buzzer. Once it gets on my nerves and I'm well aware that the power's gone out and I have to choose, do I keep running, do I shut down, what do I do? That's when I will go and turn the volume down, either to low or to off. Something that I thought of after I'd gone through and made this circuit was that, hey, I could do a mute circuit. I've not gone through all of the design for that yet, but that might be a future exercise. And that would be something cool where the buzzer starts at full volume, but I can simply hit one button, which will silence it. Because an issue with the volume control as it is, if I turn it down and then forget, there is a chance that I leave it turned down to mute for the next time the power goes out, running the risk of I may not notice quick enough when the power's gone out, in case there's something where I would want to check on my setup in that case. So I'd have to remember to manually turn the volume up right now, an auto reset mute circuit, where every time a new transfer from line to inverter power happened, it would sound the alarm until muted. That would be a cool addition, whether a future upgrade for this, or the eventual version 2 of this project. I would really like to eventually do a version 2. Bigger UPS, possibly a commercial enterprise rack mount type. Some of those, or a lot of those, already have provision for external battery. That would remove a little bit of the fun, but also a lot of the headache of this type of project, in that the inverter and the cooling would be designed for extended high-power operation right from the get-go. That would be the one where, yes, I'd finally get high-performance batteries. I would have a dedicated battery manager, possibly hybrid input, charge from the line, or charge from solar panels, or both, as required. That would be the sort of thing where I could keep all my monitors running, I could run my computer, if I had to, could pull an extension cord and run my lady's computer as well, if she needed to do stuff while the power was out. Something that I've not yet found is whether our modem will stay running or not when the power goes out. I know that I get a warning we both get warnings from our service provider that when the power goes out, within a few minutes, we'll get a text that there is a network outage in our area. We're not sure if that is simply the ISP figuring out that our modem is offline, or several are offline in our area and calling that an outage, or if that's the ISP reporting that some of their infrastructure has failed. Because that would be a little bit annoying, especially if I am uploading something. Rendering will certainly fail if the power goes out. An MP4 file has to be complete if that file is interrupted before it is fully written. It is completely useless. The data is garbage. Have to delete. Cannot pick up where I left off, and I'll have to restart the render. But upload would probably be the same thing. That's actually something I'd want to experiment with, is how does YouTube handle if the network connection just cuts off halfway through an upload? I'm guessing it's going to be somewhere along the lines of the upload fails and must be restarted from the beginning. Just, that's kind of an edge case in this modern world with typically very high uptime for networks, and it would be a waste of resources, at least to me, from YouTube's perspective, to have fault handling for streams or the upload being cut off halfway through. Alright, where are we going? Ha! This is one of the funnier ones. You know, there's a thing called a deburring tool instead of utility knife. Yeah, I'm pretty well aware of that. Several people have chimed in quite helpfully, actually, of other ways I could have deburred, some of which involved things that I had, some of which were things that I didn't have at the time, but I thought I did. I know I have another deburring tool somewhere. It did not make itself known when I was looking for it once I realized just how many holes I had to cut and how much burrs were going to form on each hole. I would have loved to found it. I still haven't, though I was convinced I'd find it the next day. Instead, I did have to go out and buy a new one. Next time, I will have proper deburring. Other suggestions were use a Christmas tree or a step drill bit. That would have made a few different things easier, including drilling the holes for the meters and sockets and switch on the battery box lid. Yeah, that would have been helpful there. It would have been useful for deburring or chamfering the holes as well. I've already acquired one of those. Next time, yeah, I'll have one. Alright. Next up, if there is anything next, I think the main thing left is a quick discussion of the parts list. I'm just going to copy the whole brick in over here. Fair warning of reading the datasheets before doing anything. I can't guarantee if parts will be available to any given viewer in any given municipality at any given time in the future. These were the parts that I used. I did put in some notes here about any sort of substitutions, the potentiometer, the diodes, general purpose transistors. Those can be just anything roughly equivalent. The MOSFET is really, really overkill. I had some concerns about the worst case as the MOSFET shut off, considering that the circuit tapers off asymptotically as the capacitor discharges. And in the worst case, it sounded like the MOSFET could spend a large amount of time in a linear regime, causing much higher heat dissipation inside the MOSFET. It wasn't so. I don't know whether I got a well-binned chip or it was simply much, much tougher than any of my requirements, or a combination. In that case, the MOSFET was so tough that it did not get noticeably hot at all during the shutoff, and would actually go from conducting fully to essentially off in a much shorter span of time, over a much smaller range of gate voltage than I expected. So someone looking to save, I don't know, 50-60 cents could easily go for a much smaller MOSFET than the one I used. The timing capacitor, any equivalent part will work. For the values in my circuit, 100 microfarads works out quite well. For any other circuit, depending on parts availability, use the RC time constant calculation in order to get a new value for the capacitor. And that is simply the time in seconds is the resistance multiplied by the capacitance. Resistance in ohms, capacitance in farads. Not microfarads, actual farads. That means that 100 microfarads with a 560 kiloohm resistor equates to the 56 seconds of the time constant. In my case, that means the fan runs for almost a couple minutes because the MOSFET has a much more sensitive gate threshold than what I expected. Better for me, better for the circuit cooling off after it shuts down. The input resistor of 1K, that can be just about anything similarly, as long as it will quite rapidly charge the reservoir capacitor to a required voltage to turn on the MOSFET and start the fan. Alright. That runs through the FAQ for that project. I don't know if anyone is still looking, because the stats are being a little bit strange for me right now. But if anyone watching has any FAQ type questions, it's not like anything got dropped into the comments on the page or onto my Twitter or anywhere really. I get it, I'm a small channel, I did drop this pretty soon before I started, and I have never done a live stream before, so didn't quite know what to expect going in. So if there's any FAQ type stuff anyone watching wants to drop, let me know. Otherwise, I might just decide to wind this down, considering we're bumping up on around an hour or so. Yeah, it's looking like it's looking like probably a good place to end it. Well, thanks for coming, everyone. Whoever did stop by. Yeah, this'll stay up for a bit. Don't know if I'm gonna edit anything or not. Or just leave it up just so that this is somewhere on record addressing these concerns. Have a good one, and to all one or two of you that came to the stream here, thanks for stopping by. I don't have a schedule for streams, but I might do this again now and then. Hopefully something a little bit more exciting, such as while I'm working on something. Have a good one, everyone.